For this demo, I'll launch ArcMap from the Start icon. All Programs, ArcGIS, and here you see I have ArcMap version 10.1. I launch the tool. So ArcMap launched, opening up some previously used projects. I'm going to close that because I want to start a new one. And all I have at this point is a blank space with no idea where my project is in the world. Actually, my demo project site is in Adair County, Iowa, so I'm going to open an ortho image of Adair County to get started. To do that, I'll use the Catalog tool to load the ortho image. I'll go up here to my tools. This icon, which looks like a filing cabinet, is the Catalog tool. So I select that, and it spreads out across my window, so I want to park it. And you notice these blue arrows that pop up. If I simply drag my mouse, my cursor over that arrow, it will actually pin it to the right side of my screen. So I drop it there, and it's pinned in place. This is a browsing tool that allows the user to access files from any connected drive or server and make the data available to the project file, what's referred to as an MXD file. Catalog also shows the user what type of data a file contains. In other words, is it a point file, a polygon, is it a layer file, or a raster? From here, I'll browse to FGeodata and the folder with orthophotos. So I go to FGeodata and I'll click on the plus sign. I'll select the plus sign next to ortho imagery. I'm going to window down, and I'm using the Adair County file, which is right at the very top. So I want to load that. I'll simply left click on the icon for the file, drag it over into my data view, and drop it. So now I have the ortho image for Adair County loaded into my project. A note on file organization. File organization is different depending on whether you are in a field office, area office, or state office. If you don't know where to access the ortho images or other files under Geodata, just check with an ArcMap user in your office or the GIS team in the state office. Now that I have the ortho image in my data view, I'm going to add the cadastral file so that I can more easily window into my project site. If the term cadastral is new to you, it basically refers to a file that has land boundaries. In this case, it has the section boundaries in the county. To access the cadastral file, I'm going to scroll back up and scroll up to the folder called Cadastral. Select the plus sign. The cadastral file for Adair County is this file. I'm going to left click again, drag it over into my data view, and drop it. And there you see a grid of the county. Those are the sections. The location of my project is in Township 76 North, Range 31 West, Section 32. I don't know Adair County that well, so I'm going to use some of the features in ArcMap to help me zero in on my project site. I'll open the attribute table of the cadastral file, search for this section, and select it so it's highlighted. Then I can window in on it. The first thing I do is right-click on the file. I open the attribute table. In the upper left-hand corner is an icon that's called Table Options. I want to select by attributes. To build my filter, the program has some nice features that allows me to build that filter without having to know all the syntax. The program also knows all the attributes, and they're listed here. My first attribute is the township, so I double click on township. equals. I'm going to get unique values. I want 76. So there I'm telling the filter that I want all the sections that are in Township 76 North. Now I want to narrow this down by range. Because I want this to be an exclusive logic statement, I use the word AND. Then I go back up to range, double click that, equals, get unique values. The range is 31 west, so I'll double click that. Now I've limited the filter to a specific township and a specific range. And finally I'm going to zero in on the section. Section, whoops, before I put section in, I need that AND. So I click on AND. Now I'll double click on section, equals, get unique values, and it's section 32. There's my filter. I'm going to select verify to make sure that the syntax is fine. And the program says the expression was successfully verified. I click OK and I apply. Now, you can't see anything different in the table. That's because I've selected just one record. I want to isolate that record, so I'm going to go down to the bottom or to this icon, Show Selected Records. I select it, and there I have only one record. That's the one that I want for the section I'm looking for. This tool is also helpful in zeroing in on that or zooming in. I can go over here to the left margin to the arrow, right click, and I can select Zoom to Selected. I'm going to close this box, and here you can see the outline of my section. The background is colored, so I'm going to change that to no fill or no color. And once again you see the ortho image. I know visually where the outlet of my watershed is. To make it easier though to follow in this demo, I've created a point file to mark that location. Just so you understand, this isn't part of the normal process. It's something I've created just for the demo. I'll load that file now. Now I've loaded it into data view, but it's virtually impossible to see with the symbol that's being used. So I'm going to change that to something much easier to see. And there is a green triangle that marks the outlet of my watershed. Next, I'm going to load one more file that will aid in using the Area of Interest tool. I'm going to load the County USGS topographic map. Why would I do that? Because I like to have a guide to help me keep my area of interest to a reasonable size without missing any part of the watershed. This will become more clear to you as I work through the tool. You can use the County LiDAR contours for the same purpose. I use the topographic map because it loads faster and has a faster regeneration time. You can use what works best for you. I'll go back over to Catalog. I'll browse to FGeoData. Let me close up the cadastral folder, and I'll go down to topographic images. And I will load the USGS topographic map. Now that I have what I need in data view, I'm ready to start using the Watershed Tools. I'll left click on the Arc Toolbox tool. It's a small red toolbox. Notice the pop-up window that explains what the tool is. Now it's floating out on the screen. Just like with the catalog tool, I want to pin it someplace. Now if I go over here to the right margin, it will pin it right to the edge of the screen. But I want to set it pinned next to the catalog tool, so I'm going to lay it over this arrow, and it's pinned to the left side of the catalog window. At the top of the window, You'll see I've already loaded NRCS Engineering Tools. If you have not done that yet, refer to the document titled Instructions for Adding NRCS GIS Tools when you are ready to begin working. The NRCS Engineering Tools are located at the top of the ARC toolbox. Left-click on the plus sign next to the NRCS Engineering Tools, and the bar expands downward. This is the first tier of the tools under the NRCS Engineering Tools toolbox. We are focused on the Watershed Delineation Tools, which is found under the Watershed Tools. So I'll click on Watershed Tools to open the next tier. Now you see the Watershed Delineation toolbox. I click next to it and open the final tier, which shows the tools I'll be working with. Tool 1 is Define Area of Interest, which you will also see referred to as AOI. I double-click to open the tool. Let's look at the parts of this tool. Other windows will look similar, though they require different input. The left side of the window is interactive, with input boxes, drop-down windows, and browse icons to search out files needed to run the tool. The right side of the window is a help screen. It provides brief, helpful explanations for each input field. If you forget what's needed in an input field, refer to the help screen. You can hide the help screen if you wish. Simply click on the Hide Help button. The first input field is Browse to select workspace. If you recall early in this video, I mentioned this input. The workspace can be created at any time, including from within WorkMap. Now let's look at the Help section of the window for instructions. Note that you can browse to a folder or create one. Also note that the Help screen recommends using a local folder without spaces or special characters. I'm going to create my workspace while I'm in the tool. I select the folder icon to browse to my computer. I want to create a new folder on my C drive under my GIS folder, which I created previously. In the GIS folder, I select the New Folder icon in the upper right area of the window and create a new folder. For this demonstration, I'm going to call it Watershed Tool Demo. Note I use the underscore to create the illusion of spaces in the name. That makes it easier to read. I hit enter. Before I can go anywhere, I need to go and select that folder. Now I can add it. The next input is the DEM. You can load the County LiDAR DEM file or the LiDAR DEM layer file into your project. I don't normally use the DEM file again after I run this tool, so I'm just going to browse to the file on the server. Click the folder. I'll select the first one, that's Adair County, and add. The next input field is Enter Your Area of Interest. One mouse click in the input field and the help screen to the right tells me I am to digitize or select a mask defining my area of interest. If I am defining an area for the first time, I will need to digitize it. If, for some reason, I have a boundary from a polygon file that I want to use, I can browse to that file and select it. I have no such files, so I'm going to define the area of interest by digitizing. I want to point out something that confused me when I first used this tool. Do you see the input field just above Enter Area of Interest? But also see that the area of interest itself is in a white box. This appears to be an input field also. But what are you supposed to do? The help screen doesn't really tell you. When I click on either box, nothing seems to happen. How do I digitize the area of interest? What I have found through experimentation is that as soon as you click into either box, the tool to digitize in the data view becomes active. I'm going to minimize the Define Area of Interest window for a moment and move my cursor around the Data View window. Notice that the cursor has changed from an arrow to a crosshair. The tool is ready for you to digitize an area of interest, which I will do now. With my USGS map viewable and my project outlet point marked, I can roughly determine the drainage area. I'm going to start well below the outlet. It doesn't matter which direction I go, clockwise or counterclockwise. I'm going to digitize around what is clearly outside the drainage area. I'm going to go turn off that ortho image so that when it refreshes, I don't have to wait quite as long. If you're looking as I do this, you'll see that my polygon is well beyond what should be the watershed boundary. When I get to the last point, I double click. So I'm going to pan over and window out a little bit so that I can see the entire boundary line. You might be looking at my polygon thinking that wasn't too terribly precise. My watershed boundary needs to be relatively precise. My area of interest does not. Now I need to bring the window I minimized back up. The next input field is called Interval for Contours. Note that the contours will be in units of feet, and that this input is optional. You can input a contour interval or use the drop-down menu to select the interval. Once again, you have options. You can choose half a foot, 1 foot, 2 foot, 5 feet, or 10 feet. Note that the help screen tells you what's available. But what if I want to use 4 feet? Well, you simply can't. You have to stay with the preset intervals in the program. I'm going to select 5 foot. The final field is called Choose DM Elevation Units. In the case of our current DM files, the XYZ units are all in meters, so there's nothing to change. Of course, it won't harm anything if I type in meters or select meters. The point is, I simply don't need to do anything. So I select OK, and the tool executes. If the tool doesn't encounter any errors, you will get the following output layers. Depth grid. Well, I need to close that window first. Okay. Depth grid, hillshade, DEM. There'll be an area of interest and contour layer. You are likely familiar with all these products, or they are at least obvious in what they represent. The area of interest, depth grid, and DEM will be needed for input in other tools. The hillshade can be used to fine-tune the watershed boundary if that doesn't end up the way you would like it to be. I've left the depth grid layer on. You can see area in various shades of blue. This is a raster file that indicates low areas that have no surface outlet between the low point and the lowest adjacent high ground. If there is no surface outlet in these areas, they would fill with water during a storm event, but in most cases, they do drain. The tool simply doesn't know where culverts and pipes are. If we window in on the Crossroads near the center of the data view window, we find several areas. There are 4 major low areas near this crossroads. One of them is an existing pond. I can see that if I turn the depth grid layer off for a moment. Here's the pond. The other 3 are created by road embankments. It's likely that all 4 have culverts or pipe outlets. You want to verify the surface drainage of these areas before calling your hydrology complete. I point this out because part of the data we are looking for from the Watershed Delineation tool is the watershed length. How we address these areas, ArcMap interprets as undrained, can have a direct bearing on the watershed length. We'll look at that in the next tool, Create Stream Network. Let me window back out to my area of interest. Now I'm ready to create the stream network, so a double left click on number 2, Create Stream Network, opens up a new window. The input for this process is simpler. The first input field is Select Project Area of Interest feature. This is the area of interest I just created in the previous step. Simply click on the drop-down button, and a listing of available polygon layer files opens up. I want the Watershed Tool Demo Area of Interest. Note that the program always adds AOI to the end of the name to indicate that this is the AOI layer. It uses the name you give the workspace folder for the front part of the name. Digitize culverts is the next input field. However, I'm not going to insert any culverts at this time, though there is nothing wrong with doing that. I want to see how the program interprets the data, and then I'll go back and add culverts after this initial run. The last input field is Enter Stream Threshold in acres. This threshold value sets the smallest value in acres of an area that contributes to a stream. One of the processes the tool does, in kind of a black box fashion, is develop flow direction and flow accumulation. The program is basically analyzing the digital elevation model and estimating what surface area contributes to each stream. The default threshold for this process is 1 acre, so once a flow path is an accumulation of less than 1 acre, the tool stops developing that stream. You can leave the default value set to 1 acre. I'm ready now to execute the tool, which is done by clicking on OK at the bottom of the window. The stream network has been created, as indicated by the blue lines in the data view, and a new layer under Layers called Watershed Demo Tool Streams. Again, notice the pattern of the naming convention. Each new layer or feature is given a name that begins with the name I gave the workspace, and it ends with a word that indicates what data is in the layer, streams for the layer I just created. In this watershed, the flow path that will be the watershed length is obvious. That's because this watershed is long and narrow. In broad, short watersheds, it might not be so obvious. I'm going to zoom in on a couple areas before I proceed to illustrate a point about stream networks and culverts. This is the ridgetop, and it apparently has some small depressional areas, kind of like potholes. The flow accumulation tool has determined that when some of these areas overflow, they contribute to the streams in the drainage area of interest. Still, other depressional areas flow into other watersheds. If your field observations tell you different, you'll need to adjust the watershed boundary, if the difference is significant. I have no information that this needs to be adjusted. For this site, I'll leave it as it is. The other area I want to window into is the Crossroads. The tool has done a reasonable job of developing streams through this area, and while the flow lines aren't drawn precisely where they actually occur, in other words, in line with the culverts, the error in watershed length probably makes no significant difference. But let's see what the tool will do if we digitize culverts into the project. I start the Stream Network tool again. I pick the same area of interest from the drop-down menu, and this time I click into Digitize Culverts. I'll minimize the tool so my view is not obstructed. As before, the cursor has changed from an arrow to the crosshair, and I can digitize my culverts. I can tell from the aerial photo that here's the outlet, and the dark blue indicates the deepest or inlet section. Here is the stream below this road, connecting that on the upstream side. Here, the outlet is all the way to the south of where the stream line was drawn. I click into the pool area. For the pond, the outlet channel lies down here. I'm going to bring that all the way up into the middle of the pond. Not exactly sure what that'll do, but we'll find out. Once finished, I bring the window back into view for the tool and execute the tool. Let's see what we get for a result. Okay, the tool's finished. I click Close and look at my streams. These flow paths look reasonable. You might notice that I never entered a layer name, and that the streams layer still has the same name as it did before. The reason is that the tool saves these files in a geodatabase that it created way back at the beginning. As I mentioned previously, whenever you rerun a tool, it first deletes existing files that it generated in a previous run, if there are any. Once again, I'm going to zoom to my area of interest. I'm now ready to delineate the watershed boundary. I use Tool 3, Create Watershed, for this purpose. The first input field is Select Area of Interest Stream Network Feature, which I just created. Now you can see how these tools build one upon the other. So I will select it from the drop-down. Next is the Digitize Outlet Input field. I can now digitize the outlet for my watershed. I minimize the window to gain full view, and then window in to the outlet location. Remember, I created the point layer that shows where I want my outlet for this demo. You don't need to do this, but you do need a good idea where the watershed outlet is. I start my line on one side of the valley and stretch it across to the other, where I double-click to end the line. I bring the tool back up. Notice there's one more input field called Enter Watershed Name. I'm going to call this WTD for Watershed Tool Demo. And just below that is a checkbox labeled Create Watershed Flow Paths. This is optional. Because I'm developing hydrology for this watershed, I want to find the longest flow path, so I check the box. The reason it has S in parentheses is that this tool can be used to develop multiple basins or subbasins in a watershed. If you did that, there would be a longest flow path for each watershed. I click on OK to execute the tool. Once complete, I close the window and zoom out to my new watershed boundary layer. Notice WDT under layers is my new watershed boundary layer. So I'll zoom to layer, and you can see how that layer and boundary fit with inside my area of interest. This is the watershed boundary layer. There is also a label in the middle of the watershed. It shows the subbasin, number 1 in this case, the area 197.5 acres, and the average watershed slope of 4.4%. Also see that a new feature has been created for the watershed length. This feature is called WDT flow paths. It begins at the outlet and it runs upstream to the top of the watershed. If I want to know what this length is, I can open the attribute table. Here I see the length given in feet as 5,124.6. When I'm ready to print this out for the file, I can label the feature so that the length is on the printout. I right-click on the WTD Flow Paths layer. I go to the Properties option down at the bottom. I'm already open to the Labels tab, so I look in the Text Stream Label field. It's set to Type. I want length, so I use the drop-down arrow to view the selectable attributes. Length in feet is at the bottom, so I select it. OK. I right-click on WTD one more time and click on Label Features. I can't see the watershed length, so I go back into Properties where I'm going to change the properties of the label. On the Labels tab, I see the Text Symbol section where I can control the font size and color. I'm going to change the size to 16 and color to yellow. Click on OK, and the window closes. I can now see the label. Once printed, I can include this in my design folder to document where my watershed values came from. Remember that if you are designing a pond, the watershed length begins at the upstream end of the pool, not at the outlet. There are several ways to accomplish this in ArcMap, but I'll leave that for another session. There is one more tool under Watershed Delineation, number 4. It's called Update Watershed Attributes. This tool is handy if you edit the watershed boundary or the flow path line. It will recalculate the watershed area, average slope, and length of flow path. For now, I'm satisfied with what I have, so I don't need to use this tool. In summary, I've just used the Watershed Delineation tool to define the area of interest, to create a stream network, and to create the watershed. These are basic elements for determining hydrology. I hope you found this video informative and helpful. If you would like help in setting up the NRCS engineering tools in Arc Toolbox, check with other ArcMap users in your office, or contact the GIS team in the state office. As with any new software, it takes some repetition to get comfortable with the NRCS engineering tools, but once you develop some skill with it, you'll be able to do hydrology quickly, easily, and in a format that is easy to share and document. Thank you.